So looking at our substitution for our second day, we're going to focus on getting our variables by themselves. A couple examples where we have a clear choice and a couple examples where we do not have a clear choice. Starting with our first system, again, since we're going to try to solve it by substitution, it's best to organize it side by side. Then we have to choose which letter we want to get by itself. So we want to look at which one doesn't excuse me, have a number accompanied with it. So 5 is with the X, so probably not this choice. Y doesn't have a number, so this looks like a pretty good choice. Let's just run through to make sure there isn't any others. 4, nope. -7, nope. So Y is the greatest choice here. That means the 5X has to go away. You get Y is equal to -5X minus 23. Since we have a Y equals, we can let, excuse me, that into our other equation right here. So we have 4x minus 7. Here is where we would have had y. -5x minus 23. We're going to distribute that -7, so we get 4x plus 35x plus, I have no idea what 23 times 7 is, 140, 161. Just want to double check that to make sure all this works out fine. So 7 times 23 is 161. Cool, that was right. Equals 5. Combine my like terms, so I have 39x plus 161 equals 5. Subtract 161 from both sides. That gives me 39x is equal to -155. Fairly certain that 39 is going to go in there 5 times, so I'm going to grab the calculator again. So 155 divided by 39. Nope. Might have made a mistake. Let's see. Okay. Oh, I did it. It's 156, not 155. That's 156. So 156 divided by 39 is 4. Perfect. Alright. Sorry about that. So with x being 4, we're going to plug it in right there. Y equals -5. Plug in the 4 for x, minus 23. So we get -20 minus 23. Oh, it's a dang it. Come on, Carl, keep it together. It's a -4. Apologize, guys. It's one of those problems. Which gives us a positive 20. Positive 20 and the -23 is -3. Alright, let's try another problem. Hopefully I don't make as many silly mistakes. Again, going to write my problem side by side. The 4x, not a good choice. -5y, not a good choice to get by itself. So we're to these two here. Both of them have a minus sign accompanying it, but they don't have a number. So either is a good choice. Just for simplicity, I'm going to get the x by itself. That means I'm going to add y to both sides. That leaves us -x equals y plus 1. I have to divide everybody by a negative. I get negative y minus 1 as my x equals expression. So we're going to take what x is equal to, plug it in over here. So we have 4, negative y minus 1 minus 5y equals 14. Distribute that 4, gives me negative 4y minus 4 minus 5y equals 14. Combine my like terms, I get negative 9y minus 4 equals 14. Adding 4 to both sides to help get y by itself gives us 18. Divide both sides by negative 9, y equals negative 2. We take that negative 2. We're going to plug it into our second equation over here. X equals negative 2 minus 1. The two negatives do indeed make positive, so I get 2 minus 1. So x is 1. So our answer is 1 comma negative 2. So what if we have a problem where we don't have an x or a y that's by itself within the problem, but we still have to use substitution? Or we're still asked to use substitution. When you don't have a clear choice, like an x that's already by itself, a y that's already by itself, we're going to look for numbers that are factors of the other numbers, or have multiples of the other numbers. So what we do is we're going to run through this one term at a time, and there's a two-step process. Does 4 go into 2? The answer is no. So 4 is not a good choice. So right above it, I'm going to put a little frowny face. Okay? 2. Does 2 go into 4? Yes. That's a good start. We have to do another check. Does 2 go into negative 6? Yes. Right here is a letter we should get by itself. There could be another potential answer. So let's do the same process. Does 8 go into 7? No. Does 7 go into 8? No. So only one good choice. Now mathematically, we could still get any of these letters by themselves and still solve the problem. But if we choose any of them but the 2, we will be creating fractions that we'll have to deal with later. Or I don't want to have to do that, since we don't have to. So I'm going to subtract 4x from both sides. That leaves us 2y equals negative 4x minus 6. I have to divide everybody by 2. So y equals negative 2x minus 3. Now we have our y equals, so we're going to take what our y is equal to, plug it in over here. So we get 8x plus 7, negative 2x minus 3 equals 3. Distribute the 7. So we get negative 14x minus 21 equals 3. Combine our like terms, we get negative 6x minus 21 equals 3. Add the 21. Negative 6x equals 24. Divide by negative 6. And x equals negative 4. Once again, there's half of our answer. We're going to take that negative 4, we're going to plug it in to our other equation. gives us 8 minus 3. So y equals 5. I'm going to try one last one just like that. Negative 8x plus 7, y equals 15. 6x minus 3y equals negative 9. So does 8 go into 7? No. Does 7 go into 8? No. Does 6 go into 3? No. 3 to go into 6? Yes. Does 3 go into 9? Yes. So there's what we have to get by itself. So we're going to subtract 6 from both sides. That's negative 3y equals negative 6x minus 9. Divide by negative 3. Each term gets divided. So we get 2x plus 3. Take what y is equal to. I'll plug it back in over here. Negative 8x plus 7. 2x plus 3 equals 15. Distribute the 7. Very similar to the last problem. Combine like terms gives us 6x plus 21 equals 15. Subtract 21. 6x equals negative 6. Divide by 6. And x is negative 1. Still only half the answer. We're going to plug it back in over here. Oops, don't need that last parentheses there. Gives us negative 2 plus 3. And y is 1.